Recording now. So context for the recording, we are testing the logic variables in the unification process written in Erlang because this is going to be the runtime library that
E-
you're going to use for the compilation of Karuta. Go.
Yeah, before we had a process for each variable. We just refactored this so we have a process for the environment, and the variables are just bindings in the state. So yeah, we're using the repo to test this out, basically. Basically. Okay, so theoretically, if we unify B with this list, we should get something, right?
Yep. So let's unify B with a list. We have something. We need to do a receive now.
And we got nothing. Hmm.
We already had this problem before when calling unify. I don't remember how we solved it, but we did.
We did, yeah. Okay, let's. Okay, spawn the environment. Oh, I didn't recompile. Actually, that doesn't matter. I didn't change the code. Ask for a fresh variable. Bind it. Let's change this to A, actually. Ask for unification. Receive end. And we're not receiving. Why?
Can you scroll up in the terminal there because I think we already faced this problem before in a previous iteration of the repo. I don't remember how we solved it.
Before it was because I forgot to send the PID.
Ah, okay, that's we're not forgetting this time, right?
No, it's right here, self.
I see. Okay, so there's something fundamentally wrong with this. That doesn't make a lot of sense, though. That doesn't make a lot of sense. We're not receiving anything.
Let's, for the sake of our sanity, for testing.
Having a catch-all, right?
Um, how does it go again? It's IO format, right?
IO format, yes.
Um, unknown message tilde p and new line, and we say m, and then we need to return the state.
I think the problem is with Unify, to be completely honest. But let's check if this does anything. Go on. Let's test it.
Uh, yeah, actually, let's do it like this.
That also works. But I don't think there's anything that there are only any other types of errors. So I don't. That's why I didn't bother. Copy. Man, just wrap this in RL wrap, man. Come on. We need to receive now. Don't forget the end.
We're not receiving, apparently.
We're not receiving, yeah. But we're not going to the catch-all on line 30, and we're
Hmm.
not receiving a generic error on line 19. So the problem is Unify. It's probably stuck somewhere. So in this particular case, it's gonna match line 76. You went too fast there.
76.
Yeah. So the first one is a reference, the second one is a list, which is gonna call unify variable, which is gonna return in line 45 the boundness, but it's gonna bind. right?
Yeah.
The variable to this value, and that should return to up there, but we are not for some random reason. So I wonder why. Could you put a print on line 77? Just for us to see if you're reaching this. Because we should. Yeah. This should be enough for restarting the repo. I'm gonna put our RL rep into the flake. I'm not gonna do this closure thing, you know. I'm doing okay. It's not even printing anything.
That's because I didn't paste the entire thing.
Ah,
See,
okay.
Karuta. Oh wait, that's not gonna work, is it? Because yeah. Okay, let's do this one at a time, right? So if we do this,
This should work. There we
this
have
should
it.
work. If we do this and then this, we should get a variable, and we
Okay.
did.
Now we call unify.
Now we call unify, and we try to receive. We printed a got here though.
No, okay, so go to unify variable down there. Well, go to the got here. Yeah.
Yeah, it
Okay,
just still
we
calls
call
unify
just still
variable.
calls unify variable. So the problem is either unify variable or in the environment behavior. So this is only doing that, okay, which seems fine, right? Seems actually pretty okay.
Hmm.
I have a question though.
Yeah.
Shouldn't we check if the variable is already bound? Because we're kind of assuming it isn't.
Mm, hmm.
Which is not,
We can.
it doesn't
That's safe,
explain our
Lemos.
problem. But
That is safe because we're dereferencing everything before. Actually, yeah, we are. Unify calls dereference, right?
yeah, unify calls the reference on line 43. Okay, but that doesn't
Hmm.
explain the problem. That fucking doesn't explain the problem. Because we are returning an OK, then. Yeah, we need a print up there. Go to the maybe on the unify. Yeah, line 16. Put an IORef after line 16. Not IORef, IO format.
Let's try again.
This doesn't make any sense though.
So,
Like, whatever it is, it's kind of bogus.
boom, create a variable, get a variable,
Man, I think we should
try
put
to
all of these things in
receive.
a function and just export a function. This is just tedious.
It unified,
It's
apparently.
unified. So the only possible explanation is that this line 18 is wrong. But how? I'm extremely confused. why this doesn't work exactly?
Let's try this, although I doubt that's the problem.
That doesn't make any sense. Make a test function that does all of these things for us, please.
I'm gonna do that. Just let's see, maybe. Expressions, they're evaluated sequentially. If all are evaluated successfully, blah blah blah. It can be short-circuited by a conditional match, which we're using in one place.
Oh, so you're wondering if maybe it allows impure things to happen. Okay, that's fair
Hmm.
enough.
I wonder if we must have bindings elsewhere. I don't think so, but
What is? Well, I don't understand the problem. What's the problem?
like the problem is we're not even getting an error here, right? We're
No, we
we're entering
unified.
here,
No, it
we
definitely
unified,
worked.
but we're not sending a
Yeah, we're
message.
not sending. That's the so what?
We're
And
not making Joker proud at all.
yeah, but my theory that it doesn't allow the side effects doesn't work because we have the print on line 17 and it does work. So what the fuck is going on? So you're telling me that you cannot do a send inside the maybe? Is that what you're trying to tell me? That would be kind of uh, dumb, I think. That would be kind of dumb.
Hmm.
Man, that doesn't make any sense. Can you go back to the maybe there? What the fuck is going on? We unified, but the receive fails. Do we need to put a variable to this receive? Like in the REPL?
No, because we're just returning the value so it can print.
Uh, I
The
don't know.
problem is that the
I would
receive
try
is
that.
blocking. The problem with Lemos is that the receive is blocking. We're not actually sending this message somehow.
Put a print after that. Yeah, make the function for God's sake. Yeah, no arguments. Just does all of these things. Yeah, and export. Don't forget to export. Thank you. Thank you very much. Ooh.
Um, Variable v. All right, because we're trying to bind it twice actually. Actually, are we?
Was that the problem
Bind
all
it.
along? That would be kind of funny.
Oh, right, because it doesn't let you. Yeah. Um, Yeah, that's very unfortunate. Actually, no, because receives should have a closed scope, I would think.
We need to nest the receives. Is that what you're saying?
You know what? Let's just use the atomic option.
Wait. How is this the atomic option? You're making an anonymous function, okay? Just to do the thing. Okay. Ah, that's terrible, man. That looks very bad, but okay.
Let's go nuclear.
And that actually does work, which is funny.
Okay,
Okay, just call test.
Karuta test.
Ah, variable bound. Okay, so it was a REPL problem. Okay. Every day you learn something new. Yeah, but now we have a problem. I also want to unify, see the value of the unification, right? And I want to do a read of this variable.
You want to do a read of this variable.
Yeah, so we need to do a deref, like send a message to the environment asking for a deref.
Okay, let's do that. Env deref a self.
And just copy line 10. We should make an auxiliary, a helper function that does only this, man.
Man, this is a very silly function.
Yeah, but like this, we can make like just make a pop function, pop, and does just that.
This is gonna spawn another environment. Is that a problem? I don't think it is, right?
I don't think so.
Yeah,
Okay,
there we go.
okay. So I think. Okay, do we want to test this exhaustively? I don't think that today is the time.
We don't need to. There's just one small detail though. Just one small detail. We need a way to check if something is a variable or not. Because, like, an Erlang system could be using references for other things, right? And we don't want to mix those up.
No, but this is not an Erlang system. This is a Karuta system. We have control over that. And for now,
Actually, we
I would
can do the
just
checking.
forbid.
Actually, we can do. No, actually, we can do the checking line here. Let me just go to
Yeah, but I still
unify
don't see the problem on
variable.
what you said. You said the Erlang system can use a reference for something else, which is correct, but this is not an Erlang system.
And also, map get um, a state
Man, I don't like when you do that. I'm trying to have a point here and you just keep going.
b state. Yeah, this is better actually. This
Yeah,
is
but
better
we don't need to do that. Why we need to do that?
because
Because
um, what if a is a reference, but it's not a reference that was created by the environment to be a variable?
that's not possible in a Karuta system.
What if we decide to use an Erlang library or something?
But then that's a separate discussion. That's not in the scope for this. Uh, but okay, I don't think it hurts to do this check. I just don't think that your premise was right. That oh, an Erlang system can do you can use reference for something else, but this is not an Erlang system. So the premise was wrong. Um, okay, anything else?
Uh, I don't think so. Maybe we should make a helper function to talk to the environment.
Such as
Because like we have Yeah, let's. Actually, should we?
No, 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 but let's go over my question first. Such as?
Like, because right now, actually, that's not really a problem, is it? Because I was thinking we have to do a receive after every send, but that's something the compiler has to worry about. It's not really something we will do by hand. So, is that actually a problem? Maybe not.
I want to check something. Did you hear what I said when you were typing that thing down there?
Yes, you said this is a Karuta system, not an Erlang system.
No, 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 but I said some more stuff.
That my premise was wrong,
I
basically.
also said more stuff.
Uh, if you said more stuff, I didn't get it.
Yeah, so okay, that's what I that was what yeah, you have a thing that when you are too focused, you stop hearing. So I said something that you don't remember because you're too focused. And I didn't know that, so I need to get used to it. I was saying that I don't like when I am trying to get a point across, but you had an idea, you rather finish the idea first before we talk about it. And that annoys the shit out of me because that means that you're typing something that we may go back on the decision. See?
Hmm.
But anyway, I need to get used to it. Okay, Marinho is focused. He's not listening to me. I will let him finish. Cool. Backtracking time?
Backtracking time. Yeah, actually, we should probably commit this first, no?
Definitely.
Um, should we keep this test for now?
I think that's better because we're gonna be using this many times.
Okay, okay, let's commit this then. Um,
And just to clarify something, um, I'm not criticizing you for being too focused. I think that's a good thing. It's just because as a co-pilot, uh, I need to get used to it.
Man, GitHub has tainted the word copilot forever.
Oh yeah, but you know what I mean. I'm not.
Yes, I
You,
know
you
what you
definitely
mean,
know
but
what I mean.
no, I do know what you mean. Um, let's reword this to consolidate. Right,
Okay, you
so
can start the
backtracking.
backtracking. Yeah, you can start that. I need to leave for 3 minutes.
Okay,
I will be back.
all right. I guess I should say something. Wow, the idea here is really. Yeah, I should say stuff. Okay, so this is something I was thinking about um, yesterday and also earlier today. The the thing here is really really simple actually because the status now is in one place. So what we can do is um, should I do this? Should I use two arguments? Let's use two arguments actually. Let's rename this to. Let's rename this to.
I'm back.
Welcome
Cool.
back. Let's.
Okay, so
Yeah,
what's the
let's.
plan? I remember that
Okay, here's the.
backtracking involves using lists.
It does, and in fact, this is something I was thinking about. Since the state is now consolidated into a single map, what you can do. First of all, let's rename this to bindings because I'm going to add a second argument here, and this is called not backtracking. What was the name that the book used? Um,
For what?
for the points that you return to when you fail to try again.
Ah, there is a name for that, but I don't.
There is a name for that, yeah.
Yeah, that's a problem. I don't remember the name. Let me grab the book. Let's check it out. So, did you manage to save the poor soul in Emacs, Magit?
Yeah, it's all working now.
That's great stuff. So, backtracking. Choice point. It's choice something. And I didn't read yet. It just came to me. Yeah, choice point. Damn. How did I remember that? Okay, so your master plan, Marinho, is to have the bindings in a separate place, which is the map, and the choice points in there. But I have a
This is going to be kind of sad actually, because I can't have this receive inside of the tail call anymore.
yeah, but I
Oh
have a
well, we're
question.
gonna.
Can't we
Okay.
just like you probably thought about this thoroughly, so I'm assuming you already have an answer. Can't we combine them in a single variable? Why do we need two of them?
We could, but then we'll have to constantly look up the first choice points to get the current bindings.
You're back.
Okay, that's fair enough. And yes, probably you're not gonna be able to use the receiving the tail call.
Uh, okay, so let's put this here. Bindings is now here. And then we do yeah, here goes here and here. Oops. Alright, that means now we can get rid of this and this close parenthesis, and we can reduce the indentation. There we go.
Okay, so my understanding, correct me if I'm wrong, is that when we have gonna swap the maybe actually, because the maybe on the unify will not behave like that because if you have a failure, that means you need to do the backtracking.
That means we need to do a backtracking. Actually, we don't need to do it here though. We can send a separate message for that.
But we don't want that because that involves copying.
But we don't need to send anything big, it's just an atom.
Okay.
Like if I do something like, I don't know, new choice, then what we need to do is do this.
Wait, I don't understand that.
And then backtrack.
Wait, I need well let you. I'm only gonna let you finish.
No, the idea is really simple. If we make a new choice point, we need to save the current bindings, right?
Oh, this is to add a new choice point.
Yeah.
Oh, okay. We're not using it. I was thinking about using, like, this. I already tried this. This didn't work. I need to try the next one.
The problem is that there's also state in the other process that's running the compiled code that also needs to be dealt with. So we can't do the entire thing here.
Wait, that sounds
I mean,
important. I
we
didn't get it. Could you repeat?
because like there's also local state in the other process that's going to be running the compiled code, right? Like local variables and such for the like local variables at the Erlang level, I should say.
Wait. Ah, it's because at this moment, when the code that OCaml is going to generate, we're gonna probably gonna be like running the first choice point, and if it fails, we need to if it fails here, we need to inform the other guy that hey, we had a failure, go back, and he needs to like garbage collect the shit.
Yes, and in fact, we need to get a return address. PID. Oops. Um, I guess this can just be an atom, no? Let's. Okay. Choice point created. And then backtrack. PID. But then here, we actually need to do a case because choice points.
How the fuck are we gonna do that, by the way?
Actually, you can just use a maybe.
Like, that sounds complicated. We need to. The OCaml code needs to keep track of the variables itself, not only the this guy, the environment behavior, but the OCaml code also needs to have a copy of the lifetime of the variables.
It doesn't need to have a copy of the lifetime of the variables necessarily. It needs to, like, it's going to have some local data, like argument passing that it has to handle, and control information, like how, like keeping a call stack and such, right? We have to deal with that basically.
Yeah, but in that case, that's controlling the lifetime. If you are in the stack, you are alive, for example.
The point is that when you backtrack, you also need to unwind the stack, you see?
Yes, no,
Back to the.
I agree with that. I completely agree with that. Man, that's gonna be a bunch of processes mimicking mutability for this shit, right? Like,
Not really, just going to be two processes actually.
oh, I thought we would mimic the stack as a process, as Magetta did with the iterator,
Why?
because it seems convenient to mimic mutability that way.
We don't need to because we have exceptions on Erlang.
Yeah, but they suck.
Doesn't matter, we can use maybes actually. That's probably simpler.
Okay. Okay, so what are we doing? We're doing the choice points. Yeah, this maybe expression thing is very convenient. Gotta say. It took them a while to notice this,
Oops.
probably, but convenience of monads. Okay, so if you have more choice points, uh, why are you calling new bindings and new choice points?
Because you can't shadow things
You
unless you do
can't
this.
shadow things.
Actually, even if you
Wait,
do this, you
what?
may need to shadow. You may call shadowing.
Wait,
Yeah.
wait, 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 wait. I still don't get it. You have a choice point. The choice point may introduce some particular variable names. That's completely fine. But when you backtrack, you go to the next choice
Um,
point. You may be using the same bindings.
no, I'm talking about Erlang. Like you can't shadow, so I can't just do bindings and choice
Ah,
points here.
yeah, but I would call these bindings and choice points choose instead of news. But okay,
Actually, those are not new. They are old, in fact.
exactly. They are all old semantically. But I guess you just meant new in the sense of okay, I can't just use bindings because Erlang.
Uh, right. So if we fail,
There are no more choice
um,
points. We just propagate.
if we fail, then we have yeah, this is just gonna be choice points. But then we need to tell the process actually that PID error um, no choice points, and then we just keep running, I guess.
You say run.
Indeed, you say run. Technically, we can just do this, I think.
Yeah, I think this is it. Is that it for backtracking? There's no fucking way.
It is, and in fact, we
Wait,
can
this is all
do.
for backtracking?
It should be.
Man, all of that.
Well, actually, I should put an asterisk here. This is it for backtracking for variable bindings, right? The other half, which is the control flow, right? Go back to the point in the execution um, where you made the choice point. That will be handled by the actual compiler in terms of exceptions,
Oh, okay, so we're still
or
gonna have the
probably maybes
headache
actually.
of like, oh, if it's a query, you do in this order. If it's a declaration, you do the opposite. All of that
Mm,
nonsense is gonna still be in there.
Not really. No, we can implement the other half of backtracking in terms of maybes and else's, basically.
Okay, so this is gonna be a shit a lot easier in comparison with the raw rings abstract machine.
Yeah.
Okay, so at least that's good news.
All right. Let's say new choice self. And actually, for the sake of visibility, I should
And
probably
make these
like,
lambdas a separate pop function. For the sake, for God's sake.
yeah, let's do
Receive v.
receive.
Okay, that's way better, man. Because look at this mess. I know this is dead code anyway, but
IO format. Um, oops. Right. So unify with dref, then we backtrack. Yeah, then we backtrack, and test pop, and then we deref DA again.
what new choice does again? Oh, it just includes the current branch to the choice points. Yeah, okay.
And this should give a different result. Yeah, so basically what we're gonna do is we're going to spawn the environment, create a variable, make a choice point, bind the variable, check that it's bound, backtrack, and check that it's unbound, basically.
Wait. Could you repeat that last part? Why it's gonna be an unbound after?
Because we're doing the unify after making a choice point.
But isn't that always the case?
No, we could unify and then make the choice point afterwards, and then the behavior would be different.
Wait. What would be the other behavior then, if you unify first and then make the choice point?
If you unify first, then you will make the choice point with A already bound, so backtracking is
Ah,
not going to
okay.
unbind it.
Actually, new choice is adding a closure environment to it, sort of. And then if you do the unify first, you are pushing into the closure the A already like bound. Makes complete sense. And something is very wrong. So a syntax error, you're probably missing a semicolon or a comma. So go to line 48. 48. Yeah, you're missing the state. No, 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 no. You need to pass this. Oh no, we changed that. Never mind, never mind. Function is unused. So there's another syntax error somewhere.
Hmm. Hmm. Okay, first of all, is this okay? Commas, 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 commas everywhere. Yeah, this is fine. Then receive, maybe, else, and
What the fuck? Whatever it is, it's weird.
mm, I forget. How do you? Man, I never remember how you space color, blah blah blah. Check. Okay, it's dash b. Git diff there.
Ah, I know the problem. It's because we need to change the arity of the export. Stupid.
Oh right, it now takes two arguments. That is true.
Fucking stupid. Just a random fact, okay? I am expecting a package to arrive today, and I actually this website has a nice feature that allows me to actually have real-time access to the person with my package. And the guy is literally blind because I am looking for 10 minutes, and he went to every single place near my house aside from my house.
That is kind of sad actually.
Okay, so he's very close to my house now. Please, guy, just use your eyes. They are there already. I know they are. Okay, he found it. They are calling.
Okay, unification failed. Why?
Education failed. Damn. Check the new choice point.
New choice.
So this is just sending the PID 46, and then 47, adding the bindings to the choice point. Oh, wait, 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 wait. We got identification failed on the error. Are we doing
Yeah.
everything correctly on line 28? Like, I feel that we should be grabbing the head out of the out of the checkpoints or something.
Why?
Because no, line 52. I see what you did. I see, I see. This is okay. So you're pushing, and then we fail. We just pop it, and then use the first argument as the bindings for the unifier. No, this makes complete sense. So there's a problem somewhere. So where should we add prints?
Hmm.
Right here,
What is
right?
the state now?
Add the print before line
You
107.
know, actually, you know what it is? We're
We're
calling
implementing backtracking,
unify.
Magenta.
Yeah, we're implementing one half of backtracking, right? Which is undoing the bindings.
Yeah, the other half is like
Oh, I
control of
see.
the stack. Go, Marinho, you were saying?
We take the existing bindings, which should in fact have the variables. Let's print the bindings, I think. IO format current bindings unification. See Karuta test. Okay, it is initially unbound.
Which is correct. Can you go to the test function again, just for us to see the order again? Because I forgot.
Okay, so we
Fresh
make an
variable,
environment, make a variable.
grab it.
Um, yeah,
We
we
grab
grab
it,
it.
then we say that this is a new choice, and then we do the unify. Yeah, that print is correct. Initially the A is unbound, so this is correct. I actually know exactly where to put the print. Go to 107. So 108 now. Add a print before calling unify variable. I think
I
the
don't
map
think we're
get
gonna
being
get here. Yeah, I
exactly.
think the map
I think
get
the map
is.
get is fucking us over. Is this the correct order of arguments? Map get. I already don't remember what map get does.
It is. It's in Unify KV as well. Actually, did we test unification of maps? Because this may be backwards.
We didn't. I actually asked you that. Should we do a more exhaustive testing? And you said what? No.
Mm,
Let me check the order of arguments for you.
I can just try it out as well. It's not like it's expensive to do it.
Yeah, it's key map.
It's key map. That's so weird.
It's backwards. Line 107.
I just flipped it though.
Ah,
Yeah,
unification
still
failed.
unification failed.
Yeah, it's key map.
It's key map. Okay, so that means. What does it mean?
Oh, makes complete sense. At this
Hmm.
moment, it's not inside the state because unify variable does that. It makes complete sense that this is false.
Actually, it shouldn't be because when we create the variable, see, it's already in the state, it's just unbound.
We did the fresh before. You're right. So this is already there, but unbound. Um, do the following. Go to the unify function in the print that you're printing the current bindings. Oh, that's not gonna print, I think. Well, but let's see. Maybe I'm wrong. I hope I'm wrong.
You were saying?
Yeah, I wanted to do the map get here on line 72. Also add that to the print. The result of the map get. Before calling unify dereferenced.
Map get, but
A state. We know that this case is gonna be a variable, okay? So I know that this is wrong in a general case, but
uh,
just put whatever.
right. See Karuta test.
Well, it is written unbound, Wait, what is the result of map get? Oh, it is whatever. Okay.
It's the value associated with that key in the map.
Okay, but we didn't print the one down there, as you can see. So the map get is fucking us over.
Is it?
It must be.
Let's
Put parentheses.
let's go
Put
back.
parentheses. Put parentheses in the when clause.
Parentheses. Oh, you wanna do something like actually let's just comment. Let's just remove this. It is easy to put it back.
No, no. Let's test the parentheses first. That's easier. Let's see if that makes any
Parentheses.
difference.
Where do you want the parentheses?
Before the is on is reference and after the state on the map get. Yeah, that. Try that. If this makes a difference, like, come on. Come on, people.
It probably won't.
And got here is not appearing.
It
It didn't
didn't.
make a difference. So what the fuck is going on?
Let's get rid of this for now. We got
Got
here.
here. Yeah, so it's the map get.
We got here. Oh, I think I might know
Please
why.
share.
Map get is going to do a lookup on the map, right?
Sure.
And then it's going to treat it as a boolean, right?
No.
Which means it's going to compare it because this is a when, right? It expects a boolean here.
Really?
I think so because
Okay, just put it
let's
back and put difference then false. Doesn't matter. We can also do that. And then just do like different, and I don't know, I don't remember how to do that in Erlang.
I think it's like this.
Operators.
I think it's like this actually.
No, it's slash, not exclamation mark.
Yeah,
Oh,
it
it's
is
actually
for
slash. Okay.
inequality. Yeah.
False.
Actually, we can just say whatever, because we don't really care what it is.
Wait, but what does it return in the case that it doesn't find it?
It. That's a good question.
It actually throws an exception.
Oh wait, on the guards,
Fuck
can you
me.
execute functions like map get?
You
Yes.
can do map get specifically, actually.
Yeah,
It's
there is a list
specifically
of
map
special
get. Okay.
functions. Sorry, Magetta?
No, I'm saying like specifically map get you can.
Yes. There is a ismap
Mm.
key. Ismap key, isn't that enough?
Yeah, that's kind of what we want, right?
I think
Let's
I
try
saw
that
it when you
instead.
were scrolling.
Yeah, let's try that instead. This is this, right?
Just search for it. Ismap key.
No, it's right here. It's just, yeah. Key and then the map. Key and then the map. Let's do is map key. Let's do the same here.
See if this works. Yes.
Yeah, that works actually.
Okay, but that's
Which
what a
means
problem
actually,
to have.
yeah, we should do the same thing here. Is map key.
Okay, but let's see the print. So received fresh variable. We created a variable. We instantiated a choice point. Then we called for unification. We actually bound the variable. Then we dereferenced it, getting the 1, 2, 3 back. Then we backtracked, and then it appears dereferenced again.
Yeah, but see, the value here is no longer the list, it's actually the variable itself, which
Which means
means
it
we
is a
know
free
this is a
variable.
free variable, yeah.
So this means that it works.
It works, indeed.
Okay. So can we start doing some OCaml now?
We can. Let me just clean this up
Yeah,
and
remove
commit.
some of the IO formats. Some of, aside from the received can we can keep. I think it's good for debugging purposes.
We should keep this, right?
And we should make a test suite for all of these things. No, let's
Okay.
remove that one. Yeah, that one can go away. The got here down there can also. We already removed
Yeah,
that
there's
one.
only these two now. Yeah.
I think that's good enough. Yeah, but we should test every single data structure type because we only tested lists. Uh,
Um, well, we actually only tested variable binding, right? Well, we
yes.
tested list matching as well. Let's do
Can you make a list with the A in the middle and then do 1 and 3 and the A should be true? Can we do that?
make a list, I guess.
Yeah, this is a
One,
dynamic
A,
language.
3.
Yeah. So I'm very curious to see what the
So
fuck is gonna
wait,
happen.
wait, wait, wait.
Yeah, it
Wait, so
dereferences
the
to 2.
A, so the A there is actually a process, right? That you are assigning to the variable, and you're trying
Yes.
to unify I see.
Yes.
It's not
Yes.
really a process, it's just a ref.
Yeah, yeah,
Like,
it's
it's
a
not.
ref that we save as a process inside the environment. Originally, the
Uh,
Okay.
Marinho's idea was to treat it as to have a process instead, but he decided to use references now.
and also to consolidate the state into a single environment process
Okay,
instead of having a
change
bunch of.
the example and remove the
Yeah.
3 from the left hand side.
I see. It's very elegant the way it is.
Okay. We'll remove the 3, right?
Yeah.
Let's remove the A here. It doesn't matter, right?
No, no, no. It matters because I want to see what the value of A is gonna be after that.
It shouldn't be anything, actually.
Wait, but in Karuta this would make the list 2 3, no? Or am I
Oh,
misremembering?
you mean like this?
Yeah,
Yeah, this should do what you expect.
and it does. Okay.
I'm actually surprised.
I am. Because when you look at it, line 17 actually looks like Erlang has logic variables now.
Try matching the head and putting a wild card on the last. Does that work?
Matching the head and putting a wildcard.
Yeah, so A pipe underscore. That's what he
Yeah.
wants.
That doesn't quite work because this is an argument, this is a data structure.
Yeah, yeah, yeah. So this is where the illusion falls apart.
Yeah, in order to do a proper wildcard, we would have to do something like this, right?
Yeah, that makes sense. Mm-hmm.
Yep. But this should work, right? This should do what we're expecting. It doesn't.
It doesn't.
Okay, so we managed to block on the choice point
Oh,
created.
I forgot this actually. Yeah.
Ah, okay. Yeah, that's gonna be terrible to have debugging, man. Terrible, terrible, terrible.
Karuta test. There we go.
And it's one.
Fantastic.
Okay. Uh,
Congratulations.
yeah, we have unification on variables, and we have backtracking. Okay.
I suppose we can do with anything like strings as well, right?
Yeah, strings are lists.
It's any.
We can even do with bit strings.
Yeah, we can
Oh,
bind a
we can
bit
convert
string to a
atoms.
variable.
You can convert atoms to lists, so you should. Can you do list of lists as well?
List of
Sure.
lists. What do you mean? Why not? It's
Why not?
dynamically typed.
I
Like we
mean,
could do.
I'm more concerned with the
Right now, we
if you.
support all Erlang primitive types.
Okay,
And there is
even
the
byte.
caveat that references can only be part of the unification process. They cannot be like values, I guess.
Mhm.
They are specially treated in our case.
And any ideas?
Yeah, no, you can do records, you can do lists of lists, you can do maps. We should have an exhaustive test suite testing multiple combinations to guarantee that that this very little code does what it's supposed to be doing. But I can implement that later. That's fine. I think we should do a commit. That's what I think.
I agree. Gold already.
Actually, before we do that, there's something I want to do. Um, yeah, this is not very nice, right?
What? Not having the wildcards syntactically pleasing?
No, the problem is that this is creating a variable, right?
Yes.
But this is meant to be a discard, right?
Um, well, we can especially
Yes.
treat the underscore inside the environment behavior to like garbage collect those things.
That doesn't quite work because we're not really using real underscores.
No, yeah, we would have to
So
pick a name that would be specially treated.
Can you put the atom wildcard?
the
The
atom
Atom
wildcard.
underscore.
But
Can
then
you
we
put
will never be
it?
able to match that atom is the problem.
Yeah, it needs to be a variable
Okay,
because of the matching.
So,
it's okay. It's okay. So here's
yeah.
here's my idea. Okay, if we
I
say
think I'm following now.
okay, if we do this, all right, hear me out. If we say discard, then we need to check in the bindings. We need to check in the bindings.
Wait a moment.
Case
Oh, we're
bindings.
gonna hash the bindings from the Karuta code, so that doesn't matter.
Discard, and this needs to be this, right?
As you want a pattern match? That's
Yeah,
okay. Easy.
yeah, that's better matching, yes.
If we have a discard, then we need to send back to the PID. Um, we need to send back to the PID wildcard, discard. And then we tail call. And then we tail call, keeping the state.
Else, we just tail call.
Otherwise, if we don't have a discard, then in that case, we need to make one. So we
Wait,
say,
make one.
I see.
yes, look at,
If you have already bound a previous discard, and that's just remaining, right?
Wait, I'm still not following. Could you repeat that?
I'm not sure if I did, but that's what I guess is the case.
Yeah, I need to see how Marinho plans to use this message discard because I'm not exactly understanding the purpose of it.
this can go away, and then the bindings needs to have
Discard.
What's that choice points?
It's for us to make closures essentially for the backtracking.
Hmm.
So, for example, when you make a choice point, this means that we're gonna try to unify, but if we fail, we try to pop the current choice point and go to the next one. So this is essentially a list of closures.
I see.
The book calls them choice points. Yeah, but now I need to ask the question. So Marinho, could you explain how do you plan on using this discard message? And
all right,
what it is
here's the
for?
idea. When we get a discard request, we say, okay, that means the client wants a variable that acts like a black hole. You need to match everything, but never be bound to anything, right? So if we don't
Mm-hmm.
have one, which is this case, we create a new ref, and this value is unique, right? So there's no way this will collide with anything that already exists. And we add it to the environment, and this is, yeah. And we add it to the environment in two places, actually. We bind this as if it was a variable, but we say it's a discard.
Sure.
And we also say there's a discard in this environment, which is this thing, which we use for the lookup up here, right? Um, this means we don't keep spamming new variables whenever we want to discard a value, right? And then,
Oh, okay, that's why you call the black hole.
That's a
yeah,
genius
and
solution.
then when we want to unify this, then,
If it's a discard, we don't. We just ignore it.
yeah, if we want to
Yeah,
unify
yeah,
it,
that's fair.
unify variable,
And I'm glad we have Marinho, man.
You're welcome. That's why you call it the black hole. Yeah,
It's like
no.
dev no, right?
Yeah, exactly. It's working like dev no. It's actually a good comparison.
yeah, it's basically dev null, essentially. That's not it. Unify variable here. Yeah, we need a special case here in case.
Yeah, you need to do a lookup, and if it see if the var is actually the one on the discard
If it's
position.
if it's yeah, if it's discard, then just don't. Right.
Yeah, just don't.
Actually, you do need to just succeed on the unification, right? Because it can be anything.
Yes, exactly.
Okay, case state of. Um,
Hashtag curly
if the
discard.
var is the discard, then okay state.
Yeah, but you are saving two discard things on the. Oh, I guess it doesn't matter. I guess it doesn't matter which one you're gonna inspect.
Um, if and now here's the thing. Um,
Discard.
if the value is a discard, we also need to say okay state regardless, right?
Mhm.
Sure.
'Cause- actually, no, that doesn't work because the value. Oh no, yeah, no, it does. If the value is a variable and it's the discard, then we need to say okay.
Yeah, yeah. Yeah, we have relations. Both can be variables. That's fair.
And then if neither of them is the discard, then we just keep doing what we were.
Okay, I have Ah, okay. The other bind that you did, because you did two extra binds on up there, right? You did a discard variable and a discard atom. The discard atom serves for this, and the discard variable serves for the lookup.
Not well, not quite. The discard variable is what we're using here, right? We're checking if this var or this value is actually one of these,
Yeah, oh, yeah,
right?
okay. I said it the way around, but you got my point, right? You made two bindings on up there because one is for here and the other one is for the lookup to get the reference of the black hole.
Yes, the other one is so we don't keep spamming new
Spamming
black
garbage.
holes. Yeah.
Yeah, okay. Okay, yeah, this is very clever. This is actually very clever. Magenta, did you
Mm,
catch this difference?
I think I'm following, yes.
Okay, so do you
So
understand why line 53 does two discard bindings?
yes, because you need to keep if you have more unification members, you need to keep discarding if the variable is still in the environment.
Yes. And the other one is for you to retrieve which variable represents the black hole.
Mhm.
So yeah, pretty clever.
I I am actually surprised you thought of that very quickly, Manin.
Yeah.
hmm.
As always, as expected. Okay, let's use this up there in the test.
Okay, instead of fresh variable, let's say
Discard.
um, that's the message name we used, right? Yeah, it is.
Oh, it's line 17,
Mm,
by the way. Don't forget to change 17 as well.
let's do this as well.
17. Don't forget.
17. Yeah, this is not meant to be.
Discard.
Yeah, discard.
There you have it. So now the line 18 is getting us the variable the black hole that we're gonna just ignore the unification. And now wildcard will. I'm curious about what's gonna be printing there. Probably nothing. There is syntax
Um.
problem.
Oh right, I
A,
need an end. I need an end.
yep. Okay.
Syntax error before on line 57.
7.
57. Let's go there.
Ah,
Ah, it's comma.
not.
56.
Comma and. Oh, yes, it's cases, so yeah, comma.
Case bindings of. Wait, no. Um.
No,
Oh,
just
it's
just.
because I copied that thing, but yeah, we don't need this.
Oh, the case is the one that finished. Oh yeah, we are calling ourselves recursively inside the case. That makes sense. Okay.
Mm,
No
Uh,
match of right hand side. Wild
ah,
card.
you
There's
deleted the
still.
wildcard from one place. Ah,
Yeah.
there it is.
No, there's still the wild card somewhere. Just do a grep.
no, it's because
Uh,
wild. Yeah, discard.
Yeah. So compile.
Damn.
Where is the
Variable
wild
bound.
card? Oh, we're not printing the wild card, so we're not gonna
Yeah,
see it.
one is there, so it worked, actually.
Yeah, one is on the A,
Um,
so that's correct. So that means
yeah,
that the
let's.
wild card should always behave like a free variable.
It should.
Cool.
It absolutely should. I'm going to print it here, and we should see another free variable here before we backtrack.
Which we do.
And there it is.
Damn.
Wait.
It's yeah,
When
it's a
we
reference.
backtrack, the reference. Oh, it's different. Okay, I was about to say they are the same because the beginning is the same, 172.0.299, but they
Yeah,
are
no, this is
different on
A.
the. Yeah, but they are different on the last point, the last numbers there. Okay.
Yeah, no, this is A.
Yeah. Okay. Awesome. So even have the bonus. Congrats, Marinho. So let's do a commit now. What do you think?
Let's do a commit. Indeed. Um,
What's on the roadmap next? Hey, we're going
Now,
pretty fast here.
okay, now we have a discussion because I was talking to Marinho earlier today in the chat about instead of compiling to the symbolic representation, compiling to Erlang.
yeah, let's compile to Erlang actually,
No, but
because
here's a
then
catch. He said Erlang AST. He didn't say Erlang. So I wonder,
that
is there
also
a difference
works.
between those two things?
Why though?
Because apparently that's a convention in the Beam community. So like probably Elixir and Gleam they are compiling to Erlang and not to the symbolic
Yeah, I
representation.
know that Gleam does. I'm not sure
And
about Elixir though.
second, because you can exploit the compiler's optimizations that way.
Yeah,
Because if
makes
you
sense. You
write
can
the,
expand and
yeah,
get
if you compile
heuristics from.
directly to the symbolic, probably there's less stuff that the compiler can do for you. So going to Erlang directly, or well, he said Erlang AST, which is the term that I want us to understand what it means.
Uh,
Uh,
Probably something that looks like the symbolic representation as well.
yeah, I wonder if
Maybe.
that's just Erlang, and he just said Erlang AST to be fancy.
Erlang and ST, and then it's just Erlang. Here, ERTS. Is that it?
I have no idea. So that's what I want us to do. Well, we need to merge this PR that
Mm,
Marinho
Section describes the
posted.
standard specification parse trees for Erlang programs as Erlang terms. That looks like it.
That looks
Yes.
like it. That sounds like it, I should say. That sounds like it, indeed. Oh, you already opened the
Let's
PR,
see.
Marinho. Just make it open for review.
Ah, man, it's so dumb.
I hope.
It's literally just curly braces, like tuples galore. That's it.
Oh, okay, that works. Yeah, so we're gonna compile to that instead of the
And
symbolic
oh,
representation.
dude, this is so cool. Ah. So check
Oh,
this
that
type of
means
here.
removing more code, right? Because we kept the register allocator, but if we're gonna do directly to Erlang, we don't need it.
Actually, we shouldn't export the environment behavior. We should do something kind of like this instead. Make environment.
Yes, yes, yes. That does the creation for us, so we can keep the API simple uh, from the OCaml. Okay, let's see.
And
Yeah,
this
I
can
saw this. I saw this
be...
post earlier today, Mageta. Is this true? It's just like tuples?
It's actually um, records, right? It seems. The guy's using that library is actually C sharp, so ignore that. But yes, it looks like just that because you can use the parser, right, to produce this.
No, yeah. So we're gonna generate that. We're gonna generate that
I
instead.
let me check here, man. Give me a sec.
Oh,
I'm not
the
convinced.
cowboy creator also said to check the OTP source code. Well, it is what
Oh,
it
right.
is.
Actually, we do need to export that, otherwise the spawn doesn't work. It's kind of sad, but okay. Bad argument.
Oh, I
Oh, right,
found it. It's
because
called the
we need to get
abstract
code.
format. So apparently, yes,
That still works.
this is how you do that.
Yeah, I just found it. Mm,
You're gonna have to under.
what
Okay,
do we
this is
need
a
though?
huge page of documentation.
There we go.
Yeah, compile forms, and then you just
Uh,
pass the forms.
Do you want
I
me to
think
open
on a...
for review the PR, Marie?
Yeah, please do, and please review. I'm going to stop to eat something.
Have fun.
But I'll be back.
While you
Sure.
do that, we check the.
Yeah, let's check the abstract syntax format.
See you in a
I also
minute.
need to read the PR.
Man, wait. Give me a sec. The
Yeah.
Erlang a wait, the Erlang abstract syntax tree is a plain Erlang term called abstract forms, which is literally what we were looking at, the .s file.
No, there's no way.
How
Be
is that any different?
no, there's no way this is the case because this would mean that we would have to have the registers information in here.
Yeah,
Okay,
that
so
which makes sense, right? You're moving things. You're like it's like a pseudo assembly at that point, right?
exactly. So, but that's the thing. If the abstract AST is the .s, then we were right all along, and the cowboy guy
Like,
just said we are
check
right.
this example here. That's strange because I checked this other page here. Look at what the guy said. This is an example with a library, I guess, the Dodger EPP.
Okay, let me check your example.
It's slurping a file and it's just parsing, and then it produces that. You see?
Yeah, you see the random numbers, the 5, the 1, the 3. These are
Yep.
the pseudo register thingies. So if
That
this
doesn't look
is the
right.
.s and this is the AST, then we were right all along.
Yeah, we were just doing what they said, right?
Yeah, so there was a miscommunication between myself and the cowboy guy.
But why
Because
did
when
you
I
talk to him, by the way?
in the Erlang server, Discord server,
Can you just ask him right now and see?
is he
Maybe
on?
he's online.
Uh, well, you are in the server.
I not actually.
Okay, let's see. Let me see if he's online.
There's this library called a library that simplifies working with the Erlang abstract format.
Yeah, no, he is not online right now. I will. Okay, I wanted to check the messages because maybe I am misunderstanding. I'm gonna send you the invite. This is an open server, so never. Like, that's not a problem. Okay, which library is that?
There's a library called Forms. Just check that. Erlang Forms
Forms
library.
Erlang.
That apparently you can convert a Erlang code into the abstract format.
Yeah, but that would mean.
We can write Erlang,
Yeah,
basically.
yeah, but at that point, why do we need a library?
Yes, exactly.
Actually, what is the purpose of this library if you have the compiler?
Debugging, I suppose.
If you want to know more about what Forms could do for you, check the following projects. Okay, meta programming. Okay, that makes sense. Erlang behaviors on steroids.
I mean, I suppose the meta programming they're talking about is literally just
Macros.
string expansion. Yeah,
Oh,
but not Lisp
not
macros, like
Lisp
that kind of.
macros. No, no, not hygienic macros, any of that. Just C macros.
Yeah, very likely.
Okay, traversing Erlang's modules AST is now as simple as traversing a list. The forms library ships the map. Yeah, this is the library purpose is if you are already programming in Erlang and you want to be able to manipulate the AST using as input Erlang. So this is perfect for metaprogramming. This is definitely not what we're looking for. What we want to know is the is Erlang's AST the .s format? Because if it is, then Ethan and myself, we were talking the same shit.
And you've got to be kidding me that the author of Cowboy literally wears a cowboy hat.
Oh, he does.
That's so based.
He does. And look how based the last messages are. Like, I don't use rebar 3 because I wrote erlang.mk. Like,
That's crazy.
I have a tool for building shit.
Which is older, I think.
Yeah, it is older, I believe.
Okay. Man, from what I understood, what the guy is saying is basically you target the community is so small that you can actually go and talk to like very important people. It's very interesting. Like I literally joined the LFE Slack channel, and then guess who pinged me?
The author of the
Robert Verding.
LFA?
Yes,
Who? Yeah.
Robert Verding.
No, but he pinged you out of nowhere?
Yes, he just said, "Oh, welcome to the server. How are you doing, man? Blah blah. How did you find LFE? Oh, I actually know LFE for quite a while. Like crazy.
Really? I'm gonna have to join that Slack at some point. Oh, but the guy's gonna be disappointed because we paused his project.
Well, what if he gets so excited that he convinces us to redo everything we did in LFE? I'll help you guys.
No, no, no. I
Then
mean, I mean my junk, right? The project that's gonna use the most out of LFA as possible. We paused it. We're gonna get back to it some point, but right now we want to focus on getting Karuta back to what it was before the fork.
Yeah, but
Okay.
this library looks useless to be honest for
Yeah,
us.
for us, this is definitely not what we're looking for. What we
There's a
need to
Rust library called Earl AST. Rust representation of abstract syntax trees on Erlang modules.
that also
That
sounds like for
looks
metaprogramming.
that looks like shit that the Gleam people wrote.
Damn, that's tough. That's tough to say, man. Tough to say. Okay, so okay, let's continue our journey. So what is the .s? Erlang compiler? I think I searched for
While you
that.
do that, let me just go to the bathroom real quick.
Compiler. Nope, I don't want that. There we go. I'm not gonna be able to remember. Erlang intermediate representation. Erlang Erl C. Yes. Dot S. There we go. Assembler source code. So what happens if I search for syntax? Erlang abstract syntax tree. Okay, so there's a function called Erlang parse. So Erl parse. Erl parse. This module is the basic Erlang parser that converts tokens into the abstract form of either forms, expressions, or terms. The abstract form is described in Earth's user guide. Notice that the token list must end with the dot token to be accepted to the parse functions. Okay, here it is. It's the same thing. I should share my screen. Magenta, are you back?
Yeah, no. Wait. Let me sit down.
The functions are
Let's
also used
sit
as input
down.
and output for parse transforms. See the compile module. Do you have
Wait, what is
examples?
this? ABS form.
Yeah, I'm trying to figure out if the AST is the symbolic representation. Well, the assembler, right? That's the correct terminology. The assembler code. When you use the function rep to denote the mapping from a link source code construct, a module declaration consists of a sequence of forms, which are either function declarations or attributes. Hmm. Each field is a record. Atomic literals. Yeah, this. What is A and an O? The word NO in this section represents an annotation and denotes, among other things, the number of the line and the source code where the construction occurred. Yeah, this sounds like the symbolic representation.
Section represents
Several
annotation.
instances of NO in the same construction can denote different annotations.
Mm.
Ah,
So this is a way to convey the source file with the
the location.
that solves one of our problems already.
Yeah, this we're gonna. Well, we don't have the locations. That's the problem number one. We're gonna have to figure out how to get main here to speed those out.
I think that should be trivial.
Well, I
Like
definitely
if
hope so.
fs parsec, which is just main here, but for F sharp can't do that. I suppose main
No,
here
it's
can
not
do as
about
well.
it can or it cannot. It definitely can. The question
Yeah,
is
but
how easy
I
is
I
to
don't think it's
discover
a
that.
lot of yeah, probably not a lot of concurrentations. Main here position.
Where is chapter 7? Yeah, so here's the thing.
Yeah, here you can get on the Lexing position info.
Okay, so that's what well, we can do that today. We only have 30 minutes left.
What do you mean? There's a whole night.
No, I will have to go. I can tell you that. But you guys can continue, no problem. Yeah, this is different than what the documentation is saying because
Why are you doing that?
this is like atom. You see the atom here?
Yeah.
Well, but this is for a function information. What if you have a literal? So where is the example with a literal? Because well, but even if it's a function, you should be able to tell the location. So maybe either the book is outdated, which is possible, or they are
Book is
different
quite
things.
new.
Or they
Isn't
are
the book
different
quite
things.
new?
I don't remember. I don't know when the book was written, to be completely honest.
I think it is quite new, like a couple of years ago. And I don't think there was ever a breaking change in Erlang
There
since the beginning.
was no. The book says that there are differences in on this level of the representation. They change in um, most the most amount of changes are in major version bumps.
So they probably change. Well, they probably don't change the structure, but just where things are. That's probably the case.
Yeah, Yeah, probably they don't. They rarely change the outside syntax, which is one of the reasons that people write Erlang. They compile to Erlang because it's more stable. But they may change this level of the representation. But yeah, actually the book. Let's read that. I think that's pretty interesting. So the beginning chapter 7. Here we go. The beam has two different instruction sets: an internal instruction set called specific and an external one called generic. The generic instruction set is what could be called the official instruction set. This is a set of instructions used by both the compiler and the beam interpreter. If there was an official Erlang VM specification, it would specify this instruction set. If you want to write your own compiler to the beam, this is the instruction set you should target. If you want to write your own EVM, this is the instruction set you should handle. The external instruction set is quite stable, but it does change between Erlang versions, especially between major. The other instruction set, which is the specific, is an optimized instruction set used by the beam to implement the external instruction set. To give you an understanding of how the beam works, we will cover this instruction set later. The internal instruction set can change without warning between minor version or even in patch releases. Basing any tool on the internal instruction set is risky. So I think this instruction set is probably the one that does the moves. So like if you see a
Yes,
move,
that's what it looks like. Yes.
I think this may be the. Actually, no. This is the internal symbolic representation version. This.
When compiled,
You see the dash s here. So this
yes.
one is already the. What my understanding is the generic one, the generic instruction set.
Like they don't give a specific. Okay, but if this is not the,
Specific. This is the external generic. Which
what
one
is
is
the
the
other? How
specific?
does it look like?
Yeah, let's see if there is anything for me to click.
Oh, but the byte format is.
We will cover this instruction set in the online appendix. A complete list of instructions. Yeah, so let's search for specific. Aha! Transforming from generic to specific instructions. So a simple transformation looks like this. So you transform this, and these are two separate, I guess, generic definitions. You parse them, like you map them to this specific one, maybe. Is the instruction that the pattern first has to match. This can be either a generic instruction that the compiler has emitted, or a temporary instruction that optabs has emitted to help with transformations. Yeah, so move is classified as a generic one, I guess. Is the name of the generated instruction together with the name of the variable. It is possible to generate multiple instructions. Yeah, so move return is the specific one, and move is the generic one. So move is classified. Damn. Yeah, so move return is specific. And the code is all in C.
Oh, that's what probably why.
uh, are they generating this? What the heck? What the heck is this percent macro?
That I have no idea. Okay.
Yeah, this is C, right?
Looks like C. I wouldn't say
Wait,
it
are
is
they
C. It looks
expanding
like
this to this? This packs three
that is
arguments into one
possible.
machine word, which halves the required memory for this instruction. Yeah, they're even doing the shifts. Okay, so we are definitely not touching this specific representation. Yeah,
I
and then
think
we go
that's the
to
path to insanity. Yes.
yeah, that would be very bad. But anyway, so the question we still haven't answered the question: is Erlang's AST this then? This the AST?
That looks like a bytecode format, not an AST, which is strange.
Okay,
if it is done AST.
okay, but if you search for Erlang abstract syntax tree, I don't know. Yeah, he opens the abstract format, so what we were reading before, which is not which again seems kind of different, right? Because if you go to the atomic literals, this is like, oh, maybe the book was trying to simplify it to look at to be simpler. So in the atom, maybe it could be a triplet instead of a pair. But the book didn't do that because it would add noise to this shit.
Eh,
We can
uh,
answer that question. We can open
we
Emacs
can
and
reproduce it, yes.
try to see if we have location information if we just do it. So if I do programming world,
I'm back.
nice. No, it doesn't.
Back or black menu?
I'm back.
Okay, so here's the situation. I was discussing with Mageta if Erlang's AST is the .s format, if they are the same thing.
It is unclear, but it looks
It
like
is
it is.
it is unclear because if you look at the docs, an atom literal is a triplet with the location information in the middle. But in the Beam book, and this atom example doesn't have that. So I was considering that maybe the author, for the sake of not polluting the example with location, he just removed it. But in the file that we opened, that we generated last time when we were playing with this idea, and for some reason I closed Emacs,
Oh, the world, right?
the file doesn't have it itself, as you can see. So it was not that
Okay.
the author removed it. So it's unclear if this is Erlang AST or if they are completely separate things.
Okay, you're looking at the abstract form.
Yeah. So the answer is we don't know.
Let me see. Can we get AST with some compiler service function? Like some
No.
module inside of Erlang?
Well, yes, using the
Try
library that you
these
found.
demos. There is an Earl parse, which is like standard, right?
Oh, but
Open your REPL.
oh, it's a standard. You said.
Yeah, open the REPL.
I don't have a terminal. Let me. Oh, I haven't
Oh,
cloned it.
paste the trash that I sent on your Emacs, by the way, so you can have the thing
No, but
to
here's the
open
thing. I
rebar.
gotta go. I gotta
Oh,
go have
then
dinner. So I will finish the recording right now.